All right, thank you so much all for joining me for this lecture, and this is going to be very important because this, as usual, I have already told you that statistics is not important for paper 2 only. Okay, this is important for paper 1 only because the research methodology is there. And today's topic is one of my personally very favorite topic, and this is a regression analysis. Although we have to study in a very brief manner, there are very shortcuts. Okay, we have to study in a very short manner because in the examination practicals are not going to be asked, and a regression is very, the part of regression to be studied is very lesser in comparison with the correlation. Now you can understand that how much you have to study for a regression. A regression is not that much large to be studied. Why I am telling this? This is one of my favorite because being a research scholar, it doesn't mean that whatever the stream you belongs to, you may be the students of any subject for paper 2, but if you are a research scholar, or if after qualifying the junior research fellowship or net examination, if you shall pursue for PhD, one or other time in your life you will have to face the concept of regression analysis, because each and every research scholar has to go from the phase of data analysis and presentation, and there are number of statistical tools and techniques which are used at that time, and a regression is one of them. And you all have to understand this irrespective of your paper second background. Okay, so this was one of my favorite topic, and while teaching to my PhD research scholar fellow students as well, I have taught this concept this in a very elaborated manner. But from the point of view of our net and JRF examination, the to be studied part is a very lesser in comparison with the correlation. Okay, so now I am going to start, but as the convention is there, I have to ask if everyone is comfortable. Is my voice audible to you? Can you hear me completely? I just need some confirmations. At least 4 or 5 confirmations should be there. Navneet, can you hear me? Am I audible? Is this all fine? Well, from my side. Supriya ma'am, is my voice audible to you? Can you please reply? All right. Thank you so much. I have got the confirmation from the students. Now I just share my screen for the regression analysis. Again, I'm going to request you all to just mute your microphones and cameras as well. Okay, this topic is very important, and you have to understand the concept and subject matter only. Okay, and that would be much more than enough. Okay, even if you listening me would be much more than enough. If you listen me, there are only 3 or 4 pages involved in the complete notes, because we have shortened the notes in a way that only the relevant things are necessary to be studied. Okay, so if you listen me carefully for 1 or 2 times for a regression analysis, your concept shall be clear. I'm certainly sure, because number of students I have taught in the career span of 6 years by now, and this topic I have taught for so many times. So this is about regression analysis. Regression is a very beautiful topic. Okay, why beautiful? Because this topic is relevant for every student. Maybe there is least necessity of measures of central tendency. Maybe you don't need to understand the concept of dispersion. Maybe you don't need to understand the concept of skewness and kurtosis, or even the correlation, but no research scholar can skip the regression analysis. No one can skip this. Okay, even if you have qualified net or you have qualified JRF, irrespective the stream you belongs to, you have to study regression analysis, because data analysis and interpretation is the most important stage in the life of a PhD scholar. And data analysis is all done through from the techniques of regression analysis. This is why this is very important and one of my favorite subject, because I have done it in a very core manner by going through a lot of books, and I have taught this topic to PhD scholars as well. So from our point, whatever is necessary, I shall tell you. Okay. Before moving further, this slide is a lot of part of this slide is blank, and I am going to write here some equations. Okay. I am going to make the combination of two variables. I hope you would have understood the complete concept of correlation. And while studying correlation, I taught you that this is the relationship of finding the covariance of two variable. How two variables co-vary with each other. Okay. What is the variation of their in respect to each other? Now, what the regression is? Regression is somewhat same, but different as well. How? In case of regression, the analysis is made of at least two variables. But what is the analysis? The analysis is how one behave, in relation to another variable. This is the only definition. This is the only line from my side you have to understand. This topic is very easy, just believe me. What is this? How one variable behave in relation to another variable. That means one variable is a dependent variable and another one is independent variable. Okay. So how dependent variable behaves on the basis of independent variable. The study of this relationship is known as a regression analysis, that and nothing else. So here is 0. The centrality of the items, this is X variable, this is Y variable. X is a independent variable. Okay. And on the basis of data points of this independent variable, how the dependent variable Y, this is dependent variable, how this behaves. So on the basis of, again, we have to plot the data points, but the technique is different. The formulas are different. We have to plot the data point of Y variable on the basis of X variable. And you have to decipher and you have to evaluate their relationship. And this is known as a regression analysis. And why this is called a regression? Let me tell you the reason. This tells you how one is regressed upon another. Regressed means how one behaves on the basis of another variable. So there are two variables at least in the study of regression. One is independent, the another is dependent, and we try to find how dependent variable behaves on the basis of data points of independent variable. This is the only reason. And why this is used for a data analysis and tools and techniques, let me tell you the answer of this as well. Then you shall be able to understand why this is one of my favorite chapter. The reason is you can find why GDP is increasing. Why GDP is increasing on the basis of some other variable, economic variables, okay, like interest rate, like inflation, like some other CPI or WPI index rate. So in this way, you can find that on the basis of one variable, why the another variable is increasing and how the another variable is increasing. You can find these answers. And these are very relevant in the life of each and every research scholar, just believe me, because the regression is of number of types. So now I hope you would have understood the concept and subject matter completely. It becomes easy for you to understand right now each and every line written by us. This is, it measures the average relationship between two variables. Okay, it measures the average relationship between two or more variables in the original units of data. This is the only definition. Otherwise, what I taught you in this slide, that would be much more than sufficient. Okay, so this is saying it's independent variable, dependent variable. You have to plot the data points of dependent variable on the basis of independent variable, and you have to make the line of regression, and this is known as line of regression. Okay, so this is how the things are done. You have to find the values of y on the basis of values of x. So this is all the concept of regression analysis, although it seems very much similar with the correlation, but there is huge difference. What's that? Correlation only studies the relationship of covariance, like relationship of how a data point varies for two variables, how they varies with in relation to each other. But in the regression, we studies how the data points of one variable varies on the basis of independent variable, on the basis of independent variable. So this is the thing you have to understand. Now we have to make the classification of regression analysis as we made the classification of correlation yesterday. The first is a linear regression model, same like a positive correlation. Okay, if when a dependent variable moves in fixed proportion of the unit movement of independent variable, this is a linear regression, simply like positive correlation. This is called linear regression analysis. When the pace of change is same for both. Then non-linear, when this is curvilinear, this means this is non-linear. You have already understood the curvilinear in while studying about correlation. Contrary to linear, in non-linear, values of a dependent variable does not change by constant or absolute amount for unit change in the value of the independent variable. So this is about them. Okay, this is linear, this is also linear, but this is non-linear because it's not producing any kind of line, straight line. The next is on the basis of a number of variables. This is simple regression. If we study only two variables, this is simple regression. If we study more than two variables, but only two variables are taken into account at one time, this is partial regression. Like partial correlation, if there are three variables, but we are studying the regression of two variables only at one time, taking the third one as a constant. So this is called partial regression. After that, we shall study B and C, taking into account A as a constant. After that, we can make the regression of A and C, taking into account the constant B. So this is how partial regression works. Then here is multiple regression, when we take one variable as independent and number of variables as dependent. This is multiple regression. Suppose there is one A, B, C, D, and E, or number of variables are there. We take one as independent and we study the behavior of all together. All together means we do not leave any variable, but we make the relationship of these all. Then this is known as multiple regression. This is very simple to understand. Now regression line, the line made like this. This is a line of regression. Line of regression which tells the relationship of a dependent variable on the basis of independent variable. What I told you, listen me carefully. Okay, I'm telling you the line which represents the relationship of a dependent variable on the basis of independent variable. This line is known as line of regression. Very simple to understand. Okay, this is a graphical technique to show functional relationship between two variables. Now there are regression equations to find this. Okay, so if there are two variables, independent and dependent, how to find regression? We can find the regression with the use of regression equations or formulas. Regression equations are simply the formulas to find the line or the regression coefficient. Okay, so what are these formulas? Okay, so before moving to the formulas straight, I would like to tell some of the methods of drawing regression line, because we have already understood about regression line. This is the line which represents the behavior or the dependency of a dependent variable on the basis of an independent variable. Now, these lines can be made in two ways. First is freehand curve. Okay, freehand curve. When we don't use any kind of graph, we just plot the data points. Okay, this is independent variable, this is dependent variable. When we plot all the data points and when we make a regression line, okay, so this is called freehand curve method. This is also known as scatter diagram. Very simple method to construct regression lines. At the same time, it is crude and very rough, and it is very rarely used, believe me. Then, in this method, paired observation of variable are plotted on a graph paper. Okay, you can take graph for just freehand as well. Like years have been given here and the profits have been given here. When you plot these, okay, by taking years on the x-axis and profits on the y-axis, and when you shall plot it, that shall give you the on the basis of a time the profit, and this will be known as a freehand curve method. Okay, so this is how you can plot this. We take time on x-axis and data on y-axis. The graph there shall show point for every point of time. Okay, this smooth hand curve will be known as the simple freehand curve method. The second is method of least square. Least square includes a formula. Okay, formula. We have to plot in a very systematic way so that the sum of squares of deviations from actual values are least. Let me tell you the deviations of a dependent variable. Suppose this is dependent variable 1, 2, 3, 4, 5. Okay, so this is independent variable 5, 6, 7, 8, 9. Okay, we are taking the deviations. Deviations from mean, okay, from or actual y values. When you take the deviations 5, minus 6, minus 1, minus 2, like that, and when you scare these, okay, and these should be minimum, this method is known as method of least square. Again, understand from me. Okay, this is when you write both the data points and when you find the deviations, and you have to find the deviations in a way that their sum should be least. This is why this method is known as method of least squares. Now I'm reading the lines. It's saying, according to least square method, the line should be drawn to the plotted point in such a way that sum of squares of deviations of actual y values from computed y values is the minimum or the least. So this is how the least square works. It includes the formula, because first of all, you have to find the computed y values. Only then you can find the deviations. For finding the computed values, this is the formula. Okay, so there are two regressions when there are two variables. Okay, so first will be regression of x on y, and the second will be regression of y on x. Okay, so there are two regression equations in two variables relationship. Okay, so first here is the regression equation of x on y, second is the regression equation of y on x, and this is represented as this. bxy stands for regression coefficient of x on y, and byx stands for a regression coefficient of y on x. These are just description of the formulas. You have to understand only. For learning or for cramming reason, basically, you have to understand this. Okay, this or this. You can understand, you can comprehend, you can remember, you can cram, you can do anything, but you have to remember this formula. Don't solve practical, but remember this formula. Because if the question for match the columns is asked, then you have to answer by which formula the regression equation sufficiently fits. Okay, So I am going to explain you this formula. This stands for R stands for correlation. This stands for standard deviation of X series. This stands for standard deviation of Y series. And in case of Yx, you have to take the standard deviation of Y in the numerator and standard deviation of X in the denominator, and multiply this by correlation coefficient, and that shall give you the value of a regression coefficient. Regression coefficient, and this is also known as computed Y value. Y value, okay. And you have to make the deviation of actual Y values from the computed Y value. And when you take the deviation, you have to scale these deviations. And after scaling the deviations, you have to make the sum of these, and that will be known as method of least square. So this is all about this method only. This formula is to be remembered. Now we have to move further for the properties of regression analysis. These are very important to understand and very easy because you have gone through from the concept of correlation. So both regression coefficient Bxy and Byx cannot be greater than unity. This is very obvious. It cannot be greater than 1. Okay. Either both are less or one must be unity. Okay. Then both the regression will have same signs. Whether you are finding the regression of X on Y or Y on X, these shall have same signs, either positive or minus. Then correlation coefficient is the geometric mean between regression coefficients. Okay, this property I taught you yesterday as well. Regression of X on Y multiplied by regression of Y on X, and when you find square root of under root of this, then that shall give you the value of correlation. Okay. The fourth one is arithmetic mean of Bxy or Byx. So this is arithmetic mean. This is always greater than or equal to correlation. This is always greater than or equal to correlation. So arithmetic mean of both the regression coefficient is always greater than or equal to correlation coefficient. You don't need to solve this, but you have to understand and you have to read and remember this. Then, since regression of X on Y is this, we can find any of these 4 values. If we know the other 3 values, that means if we are given with all these values, we can find this. If we have been given with this, this, and this, then we can find the standard deviation of X. If we have been given with this value, or this value, then we can easily find standard deviation of a Y series. Okay. So this is the very simple property, and mathematical operations can be applied easily. The next is, if standard deviation of both the series are equal, standard deviation of X and standard deviation of Y is equal, then correlation shall be equal to regression coefficients. Correlation is equal to regression coefficient of X on Y is equal to regression coefficient of Y on X. This is very simple to understand. If the standard deviation of both the series are same, then these equations will have same effect. The next is, if R is 0, if correlation is 0, then both the regression coefficient will also be 0. Okay. Then if both the regression coefficients are same, like regression of X on Y and regression of Y on X, if both are same, then correlation will also be same with them. This is the 8th property. And the last one is, regression coefficient are independent of change of origin, means plus minus of any item with the items of values of individual series does not affect the value of regression. But these are not independent of scale. Multiplication and division can make the effect in the values of regression analysis. So this is the last property. Now only I think 2 concepts are left, then a regression analysis will be over. This is very important. Once this was asked in the examination, and we are giving you only those things which are necessary from the exam point of view. Otherwise, regression is often so many types from the research point of view. What is standard error of estimate? When you have found the value, when you have found the value of a regression line, okay, when you have find the regression line, but data points are scattered all around, data points are scattered all around, you have made the line, study of the variation between data points